This is a spiral galaxy as wide as the Milky Way, and it should not exist. James Webb is watching it turn in a universe only 2 billion years old. So either galaxies grow up far faster than every model allows, or the clock we use to date the universe is wrong. One of those has to be true, and both of them break something we were certain of. Astronomers call it the Big Wheel, and the closer they look, the worse it gets. It is 3 times larger than the rules permit for its age. It holds the mass of hundreds of billions of suns, and it spins in smooth, ordered circles, the way galaxies only manage after billions of years of settling down. A finished wheel, turning calmly in a cosmos that had no time to build one. And right now, no one studying the early universe can tell you which of our certainties just cracked. Start with what the telescope actually sees, because that is the part nobody disputes. James Webb was pointed at a patch of sky near a bright distant quasar. In the corner of the frame sat a faint smear of light. Nothing unusual at first. The early universe is full of faint smears. But when the team pulled that smear into focus, it was not a smear at all. It was a spiral. 2 great arms wound around a bright central hub, the same shape as the galaxy you live in. That shape is the whole problem. The light from this object has been traveling toward us for most of the age of the universe. When it left, the cosmos was barely 2 billion years old, less than a sixth of its age today. We are not looking at the big wheel as it is now. We are looking at a photograph of the deep past, a snapshot from a time when galaxies were supposed to be young, small, and unfinished. Nothing about this one is unfinished. Measure it edge to edge and it runs about as wide as the Milky Way, a galaxy that took more than 10 billion years to grow into its current form. The big wheel reached that size in a fraction of the time. It holds the mass of hundreds of billions of suns packed into a structure that looks calm, settled, and old. In the language of the people who study these things, it is a mature galaxy. The trouble is that maturity takes time, and at this point in the story, the universe simply had not had enough of it. And it was not coasting toward retirement either. The same measurements show the big wheel still ablaze with new stars, forging them many times faster than the calm Milky Way manages today. So this is not a galaxy that grew up fast and then went still. It was caught in the act, already as wide as a finished spiral and still building, burning through its gas like a furnace someone had lit far too early. Big, settled, and somehow still roaring, all at once, all before the universe had any right to allow it. If you want to keep score on this case as the evidence comes in, subscribe now, because that is the one thing this channel does. Real objects, with numbers that should not be possible. So here is the scene laid out plainly. A full-grown spiral, the size of our own galaxy, sitting in a universe far too young to have built it. Every other galaxy from this era that we have ever photographed looks like what the theory predicts. Small, clumpy, still under construction. This one looks like it skipped the entire process. And the closer the astronomers looked, the stranger it got. To understand why a single galaxy can rattle the people who study the cosmos, you have to know what the early universe was supposed to look like. The theory is not a guess. It is built on decades of measurements, and it makes a clear prediction. In the beginning, there were no galaxies at all. There was gas, mostly hydrogen, spread thin and nearly smooth with faint ripples where matter clumped a little denser than average. Gravity went to work on those clumps. They pulled in more gas, lit their first stars, and grew. But growth like this is slow, and it is messy. Small clumps collide with other small clumps. They merge, tear apart, and merge again. For the first few billion years, a galaxy is less a structure than a pileup, a chaotic knot of gas and young stars crashing together in the dark. Order is supposed to come later. A smooth, flat, spinning disk with graceful arms is what a galaxy settles into after billions of years, when that violence finally calms down. Our own Milky Way did not look like the Milky Way until the universe was well into middle age. That is the rule the big wheel breaks. The simulations, the ones tuned to match everything else we see, say a disk this large should not exist when the universe was 2 billion years old. Run the models forward from the Big Bang, and at this age you get messy pileups, not a finished wheel. When astronomers compare the big wheel to what the simulations allow, it comes out roughly 3 times too big, not slightly ahead of schedule. 3 times larger than theory permits for its age. There is a comparison that the people who first described it kept coming back to, and it is the cleanest way to feel the problem. Imagine walking through a village from the Stone Age, mud huts and cooking fires, and finding in the middle of it a finished glass skyscraper. Not the foundations, not the scaffolding, the whole tower, lit and occupied. You would not assume the skyscraper was a fluke. You would assume you had the date wrong, or that you did not understand how buildings get made. That is exactly the position astronomy is in. The big wheel is the skyscraper. The Stone Age village is everything else we see from that moment in cosmic history. And the question is not whether the wheel is strange. The question is which of our certainties has to give way to let it exist. The first suspect is the easiest one to hope for because it would make the problem disappear. Maybe we measured it wrong. Maybe the big wheel only looks impossibly large and old, and a careful second look would shrink it back into something ordinary. This is the responsible place to start, and the astronomers started there themselves. So walk through what they actually pinned down, because each measurement closes a door the skeptic would like to leave open. Begin with the distance, because distance is everything here. A galaxy can look faint because it is small and close, or because it is enormous and far. Get that wrong and every other number falls apart. To fix the distance, the team spread the galaxy's light into a spectrum, the same way a prism splits sunlight into a band of colors. Stretched into that band are specific fingerprints, features that always sit at the same place. In the big wheel, every one of those fingerprints had been shifted far toward the red end, dragged there by the expansion of the universe during billions of years of travel. The size of that shift gives the distance, and the distance is not in doubt. The light left when the universe was about 2 billion years old. That number is measured, not assumed. And pinning it this firmly is not easy. For most faint galaxies this far away, astronomers can only guess the distance from a blurry smear of color. The big wheel was bright enough and sharp enough to do it the hard way, fingerprint by fingerprint, which is exactly why its numbers cannot be waved off as a bad estimate. With the distance locked, the size follows directly. You cannot make the galaxy small and nearby anymore. At that distance, the width we see on the sky translates into a true span about as large as the Milky Way, and the brightness, spread across that span, adds up to the mass of hundreds of billions of stars. Each of these is an observation, not an interpretation. The redshift is measured, the width is measured, the brightness is measured. The skeptic's hope was that one loose number was inflating the whole picture, that the big wheel was a trick of distance or a smear that only looked organized. It is not. The more precisely each piece was nailed down, the more solid the impossible object became. So the first suspect does not hold. We did not measure it wrong. The wheel is really that big, really that heavy, and really that early, which forces the case in a harder direction. If the object is real, then something we believed about how galaxies grow, or about the universe that contains them, is the thing that is actually broken. And the next measurement, the way this thing moves, is where the case stops being about size and starts being about time. The size of this galaxy is strange enough. The way it moves is the part that does not let go. When the team measured the big wheel's spin, they found something far more disturbing than a big disk. They found a calm one. The whole structure rotates in smooth, ordered circles, the outer edge sweeping around at roughly 300 kilometers per second. Every part of it turns together, like a record on a turntable, with almost none of the chaotic, churning motion you would expect from a galaxy still being assembled. They can tell because one edge of the disk is sweeping toward us while the other sweeps away, and the light from each side is shifted by exactly the amount a clean, organized rotation would produce. Not a tumble, not a slosh, a steady, patient turn. That ordered spin is the real fingerprint of a grown-up galaxy, and here is why it matters so much. A young galaxy is violent. Gas pours in from every direction, clumps slam together, and the whole thing sloshes and tumbles with no settled sense of up or down. It takes a very long time, billions of years of that motion gradually averaging out, before a galaxy stops churning and starts to simply turn. Smooth rotation is the signature of a system that has had time to calm down. It is the cosmic equivalent of still water. And still water does not happen overnight. There is an even sharper way to see the problem. In the nearby universe, there is a tight relationship between how fast a galaxy spins and how much it weighs. Heavier galaxies spin faster, in a clean and predictable way, a pattern that the galaxies around us have spent billions of years settling into. When astronomers checked the big wheel against that relationship, it fell right on the line. A galaxy from the dawn of cosmic time behaving exactly like the settled middle-aged galaxies in our own backyard. Sit with how strange that is. This is not just a large galaxy that formed early. It is a galaxy that somehow finished its entire growing up process, the slow part, the part that is supposed to take most of the history of the universe, and did it in the first sliver of cosmic time. A galaxy this young is not supposed to behave this old. The size says it grew too big. The spin says it grew too calm, too soon. And that is the measurement that no quick explanation has been able to talk its way out of. And remember, this is still the part everyone agrees on. We have not yet reached a single theory. We are only reading the evidence off the object itself, and every line of it points the same impossible direction. The wheel is too big, too heavy, and too settled for the moment it lives in, which means the explanation has to come from somewhere else. It has to come from changing what we believe about how fast galaxies can possibly grow. That is the second suspect. Maybe the theory is too cautious. Maybe galaxies, under the right conditions, can build themselves far faster than any simulation has dared to allow, and the big wheel is simply showing us a speed we refuse to believe was possible. If that is true, the conditions around this galaxy should be unusual. And they are. The big wheel does not sit alone in empty space. It sits inside one of the most crowded neighborhoods in the early universe, a region where galaxies are packed more than 10 times tighter than the cosmic average. This is a boom town, a place where matter piled up early and galaxies formed shoulder to shoulder. In a crowd like that, collisions and mergers come fast and often. Raw material is everywhere. A galaxy with that much fuel pouring in could, in theory, grow at a furious rate. And the big wheel is clearly burning that fuel hard, forging new stars far faster than the Milky Way does today, the output of a galaxy gorging on everything its crowded corner of space can hand it. So the dense neighborhood gives the second suspect a motive. More gas, more mergers, faster growth. Maybe that is how you build a Milky Way in a fraction of the usual time. But the same crowd that could feed a galaxy is also the thing most likely to wreck it, and this is where the suspect starts to sweat. Mergers are violent. When two galaxies slam together, the orderly motion of both is the first casualty. Stars are flung onto wild new paths, gas is torn into streamers, and what is left behind is usually a shapeless blob, not a clean spiral. A crowded region should be a demolition derby. It should produce wreckage. The last thing a constant pileup of collisions should leave standing is a smooth, flat, perfectly ordered wheel turning like a turntable. Yet that is exactly what we see. The big wheel did not just survive its violent neighborhood. It came out of it as the most settled-looking galaxy of its era. The crowd explains where the raw material came from. It does not explain how the result stayed so calm. To build the wheel this way, you need the mergers to add mass without destroying order, dozens of collisions that somehow leave the disk smoother instead of shredded. And that runs against almost everything we have ever watched mergers do. So the second suspect is real, and it has a motive, but it cannot close the case on its own. The fast growth story explains the size. It chokes on the calm. And while the astronomers were wrestling with how a galaxy could possibly grow this fast, a second crack was opening. Not in our theory of galaxies, but in the clock we use to measure the age of everything. Every number in this case has rested on one assumption, that the universe is about 13.8 billion years old, which left the big wheel 2 billion years to form. That figure is the floor the entire investigation stands on. The third suspect asks a dangerous question. What if the floor is wrong? The age of the universe is not read off a clock. It is calculated from a speed, the rate at which space itself is expanding. Measure that rate, run the expansion backward, and you arrive at the moment everything began. Get the speed right, and you get the age. And right now, the speed is the single most argued over number in all of physics. There are two ways to measure it, and they disagree. One method reads the faint afterglow of the Big Bang, the oldest light in existence, and calculates the expansion rate from that baby picture of the cosmos. It lands near a value of 67. The other method measures the expansion directly, by clocking how fast nearby galaxies are racing away from us today. It lands near 73. That looks like a small gap. It is not. These are not sloppy measurements. Both have been refined for years by careful teams, and instead of converging, they have dug in. The gap between them is now so statistically solid that the odds of it being a fluke are millions to one. Physicists call it the Hubble tension, and nobody has resolved it. Here is why that lands directly on the big wheel. If the faster expansion rate is the true one, then the universe is younger than 13.8 billion years. Younger. And a younger universe gives the big wheel even less time to form than the 2 billion years we have been struggling to explain. The third suspect does not make the problem easier. It makes it worse. The one fixed wall this whole investigation has been leaning against turns out to be wobbling on its own, and the wheel is not the only thing pressing on that wall. James Webb keeps finding galaxies that look too built for their age, again and again, earlier and earlier. There are points of light so distant we see them as they were less than 300 million years after the beginning, already shining far brighter than they have any right to. The big wheel is the most finished of these troublemakers, but it is not alone. It is the loudest voice in a growing chorus, all saying the same thing. Something about our timeline does not add up. So now there are 3 suspects on the board, and not one of them can be cleared. We measured it correctly. Fast growth cannot explain the calm, and the clock we would use to check our work is itself under investigation. At this point, a particular idea always comes up, and it is worth handling carefully, because it sounds like the escape hatch the whole case has been waiting for. People point out that time itself ran differently in the early universe. If time ran slower back then, the argument goes, maybe the big wheel had far longer to form than 2 billion years, and the paradox quietly dissolves. It is a clever thought. It is also not what the science says, and the difference matters. There is a real effect here, and it is genuinely strange. Because the universe is expanding, events in the distant past appear stretched out when we watch them from here. A flash that took one day to play out near the dawn of the cosmos can take several days to unfold as seen through our telescopes. From our seat, the early universe really does seem to run in slow motion. That part is true, and it has been measured. But look closely at what that effect is. It is about how we observe the early universe, not how the early universe experienced itself. For a galaxy sitting in that ancient moment, local time ran perfectly normally. Its own clocks ticked at the ordinary rate. The stretching only appears from the outside, looking back across billions of years of expanding space. It changes how the footage plays for us. It does not hand the galaxy a single extra second to build itself. So the slow motion effect is an alibi that falls apart the moment you check it. It feels like it should give the big wheel more time. It gives it none. The wheel still had to assemble its hundreds of billions of stars, grow as wide as the Milky Way, and settle into calm rotation within the real 2 billion years its own clock was allowed. The illusion of stretched time is something we see. It is not time the galaxy got to spend. And that is the quiet horror underneath this whole case. Every comfortable exit has been checked and closed. The measurements are sound. Fast growth cannot explain the calm. The cosmic clock is shaking on its own foundation. And the one piece of physics that sounds like it should rescue the timeline turns out to be a trick of perspective. Strip away the false alibi and you are left exactly where the hook left you, staring at a finished wheel, in a universe too young to have made it, with every easy answer already crossed off the list. So where does that leave the case? Open, which is the honest answer, and a more interesting one than any tidy solution would be. 3 suspects, none cleared. The big wheel is really as big, as heavy, and as calm as it looks, so the measurement did not betray us. Fast growth in a crowded neighborhood can pour in the mass but cannot explain the smooth, settled spin, and the clock we would use to double-check everything is caught in an argument with itself that nobody has won. Each explanation solves one piece of the puzzle and breaks another. That is not a sign the astronomers are failing. It is a sign the object is genuinely teaching us something we did not know. What would actually close it? More wheels. The big wheel is one object, and a single impossible thing can always be waved off as a freak. If James Webb keeps turning up grand, settled spirals this early, the freak becomes a population, and a population means our entire picture of how fast galaxies grow needs to be rewritten. And Webb is still looking. Every month it stares deeper into that first stretch of cosmic time, and the people reading the data have stopped asking whether it will find another wheel. They are asking how many, and how soon they will have to quit calling these things impossible. At the same time, the people fighting over the expansion rate are closing in from the other side. Settle the age of the universe and you will know how much time the wheel really had. Until then, the 2 billion years we keep measuring this galaxy against is a number that refuses to hold still. If a case file like this is the reason you are still watching, do me one favor and hit subscribe, because this channel does only one thing. Real objects with numbers that should not be possible. And the big wheel is not even the deepest cut. Out past it, even fainter, sit points of light. We see, as they were less than 300 million years after the beginning, single galaxies that have no business shining as brightly as they do. Smaller than the wheel. Earlier than the wheel. Even harder to explain. The wheel is the one you can see clearly. Those are the ones that keep the astronomers awake at night. For now, the photograph has not changed. A perfect spiral, as wide as the Milky Way, turning in smooth and patient circles in a universe that was supposed to be too young to hold it. It was already old when our galaxy was barely a rumor of gas. It will keep turning long after this argument is settled, indifferent to which side wins. The argument is ours. The wheel just spins. And the next time someone tells you science has the early universe figured out, show them this one impossible spiral and ask them which is broken. The galaxy or the clock. Right now, no one on Earth can tell you. Tell me your verdict in the comments. The galaxy, fast growth, or the clock. Whichever one you pick, you are deciding how much of the universe's own timeline you still trust.